Hey everyone, my name is Nafis Ishtiaq. Today I'm going to be presenting Logistic Regression Final Assignment 2 for our data science class. So first thing first, let's discuss what logistic regression is. Um, Logistic regression is an example of supervised learning, and it is used to calculate very yes or no answer pretty much if the person is going to have disease or not. It's like the binary yes or no answer. So, and the data set we're going to be using is like a Wisconsin's breast cancer data set. And from there, we're going to try to predict whether a person is going to have a breast cancer or not. Okay. And the libraries we're going to be using are pandas, scikit-learn, which is how we're going to have the linear regression model, pandas for like reading the CSV file, and Python. And for the assignment tasks, there are like 8 tasks. So because of that, I was thinking I might divide the video into like 2 parts or 3 parts, depending on the steps. If certain steps gets too long, I'll stop it there. So first one, we have to like download the data import successfully from the data frame, create a histogram for the size and shape of the UNIF cell, create a joint plot using Seaborn, investigate an invalid missing any data to deal with it, and split the data into train and test sets, create a logic regression classifier and train using your training data set, and make prediction using the test data and generate confusion matrix for your results, generate the confusion matrix and compare the accuracy of the results of previous steps. And it's pretty straightforward. So now I'll see you guys on the next one where I already coded the assignment. I'll explain step by step how I did it and why I did it this specific way. And I'll see you guys on the next one. So welcome back everyone. As you can see, I've already coded the assignment in here. So I'll explain step by step how I did it and why I did it this way. And here as you can see, I imported some of the libraries here. And so first thing first, I'm gonna download the first example is like download data and import it successfully to pandas as a data frame. I just want to make sure I'm using it as well Dataspell as my data science IDE because I prefer that since it's a judgment product. So that's why my thing looks different. So let's get started. So as you can see, I'm gonna import the data here, run cell. Okay, so as you can see, the data are here. ID, UNIF cell size, shape, margin extension, bare knuckle, and other like data showed up there. Okay. And the next one says create a histogram of the size and UNIF cell shape. So it's pretty easy. As you can see, breast cancer.data.plot. I passed in the cell size there and cell shape there, like this one, this two, and it's a kind of histogram and label, and just do it that way. So if you run it, see, it looks pretty easy to do. The next one is create a joint plot using Seaborn. So we have to do the same once again. So X is UNIF cell size and Y is UNIF cell shape, and data is breast cancer.data. So let's try that. Okay, that's that. Great. Now this is the number 3 section, which is pretty long. So because of that, I'm gonna walk through the number 3 by itself in the next video, and I'll see you guys on the next one. So welcome back everyone. This section specifically, I'm gonna explain number 3 because number 3 is one of the toughest one I think I had to deal with because it took a lot of steps to understand what was going on. So first, I'm just gonna check if there's any null. There's no null data. But if you go to the breast cancer data, you'll see in like the question mark there, and that counts as like invalid data. Either I could drop the column or I could do something else. So I decided not to drop the column. So first what I did is I looked for the null values with the regex. So in here you can see breast cancer data.index, breast cancer data bare knuck. Then I checked on the regex if any other values are there or not. And I checked on the cases, 2 flags and NA none, bunch of other stuff to see if there's any null values or not. And if I print it, these are the indexes where the question mark exists for the bare knuck. And then I replaced it with the thing of 0, with the index value of like just a 0 thing, just to make sure this is like no question mark is in there. then if you print it right now, you'll see like that 0 string is there. But as you can see, that size still is the object, but so I wanted to convert to a int. So I convert to an int. Then I also did is, then I got the mean for the breast cancer bare neck, that mean, then which was 3.4 or something like that. And based on all the indexes that I found, then I just replace the data with bare neck mean. It's just like a normal Python program. I know there could have been easier way to do it, but I followed like a programming approach, since data science is not like my strength. So I did whatever I'm good at and I made it that way. So then based on that, as you can see, breast cancer data is like 3.46, and these are the data types are for there. So next one, I'm gonna explain the rest of the questions. I'm sorry this was long part, but I had to explain it on how I did it and why I did it this way, and I'll see you guys on the next one. Okay, so welcome back everyone. Let's work on the other side, other part of the questions. I think this would be question. I'm just gonna double check on the PowerPoint if you don't mind. Question 5 to 8, which are left, because I did the rest, I think. Okay, so first I decided to drop the ID data set because I think that was kind of unnecessary data set and we really didn't need it. That didn't suit any purpose, so I decided to drop it. So I'm gonna run the cell. Just gonna run that one again. I think I dropped it already, so there's no point doing it because thread functions already, so there's no point running it again. Then as you can see, then I have the breast cancer data here, and I decided to put the class as independent variable and the other one as dependent variable because I just wanted to know, because I'm not so sure if the class or mitosis and other ones, so I just picked class because that's the one that made more sense to me because the numbers were like more similar that way. So I just took like a 2 and 4, I guess, as like classes for it. Okay, then create a logistic regression classifier, train it using the data set. So in here, as you can see, I created the X train, X test, Y train, Y test, and I used the train test split with X and Y, and I used like 30% of the data set and random state of 40. So each same time, that means like same result will be created every times. And as you can see, logistic, I said the random state as 40 as well, to make the data to be clear as possible. And there I'm just training the data set, X train and Y train. And that's it, I think, for these ones, and I'll see you guys on the next one. So the next part we have to, I'm going to explain what I did again, like before, if I went too fast. So we had to create a logical regression classifier and train using the train data set, which I did here, X train, in here actually. I should have put that down there, but same thing. So X is breast cancer data, and Y, I'm just putting the breast cancer data with the class in there. And there are all the training data set with the train data test split, X and Y variables there, and test size 0.3 and room state is 40 there. I use class because I don't know much about cancer. Since I saw class kind of had the same value or something like that, so I chose class as like the independent variable there. And then I have the logarithm with the random state 40. I use 40 to make sure like same results is produced every single time. Then I train the data set with X train and Y train there, with the random set of 40. Make prediction using the test data set using confusion matrix. Before I go, I need to talk about what confusion matrix is. So let's go to the PowerPoint and take a look. So what is a confusion matrix? Confusion matrix is a table that used to define the performance of a classification algorithm. And confusion matrix visualizes and summarizes the performance of classification algorithm. And there are like 4 parts in the confusion matrix, which are true positive, false negative, false positive, and true negative. What does true positive mean? True positive stands for the number of patients who have been properly classified to have the cancer, I would say, and meaning they have the cancer. they're most likely to have the cancer, I say. The true negative is the number of patients. It's like who are classified as healthy. They don't have they don't have the cancer, breast cancer. So then false positive represents the number of misclassified patients with the disease, but they are actually healthy. But they're also known as, so they don't have cancer, but they're still classified they might have cancer as well. And false negative is represent the number of patients misclassified as healthy, but they actually have cancer. This is known as type 2 error. So let's go now take a look at that. So in there I have the make prediction. So it's there where I predict dot shape. I did it on the basis of X test, and I have the shape in there. And if I do it's 99.4%, which is very good. I don't know why, but maybe because of this random state, if I got rid of, maybe it would be a little bit lower. Then I did the classification report as here as well. I just want to see what was going on there. So this is the classification report. It's like macro average and all the other statistics are here. So then, and there I have the generate the confusion matrix. So let's try to run this. Start the last part. And as you can see, this is like a false positive, like from before. If you look at the PowerPoint, 139 would be a true positive, and 2 would be false negative, and 0 would be like false positive, which is good. That's why they did not find any. I said the false positive, I mean they did not find any error. So true negative is like 69, which is very good, I think. Then from scale, I improve accuracy score. Then I did the accuracy score here again, same as before, which is 99.4%. And that's it for the assignment. I'll see you guys in the next one.